morning. Our next presenters are Pedro Alfaro and Robert Lotterbeck, who will talk about their senior design project. Thank you.
Good morning. Thank you all for coming. As Marco said, my name is Rob Schlotterbeck.
I'm Pedro Alfaro.
Today we'll be talking about our Azteca Milling warehouse redesign project. So to get things started, first we're going to talk about some background information about Azteca, as well as their parent company, Gruma. Following that, we will discuss the project requirements, and our project is divided into two main sections. First, the firewall relocation project, and then also a fork truck traffic reduction project. After that comes the design analysis for both the firewall and the fork truck traffic project. Then an economic analysis, so we'll look at the implementation cost as well as the design cost. And then we'll take some questions.
All right, I'll start with Azteca. Azteca is part of Gruma, which is Grupo Maseca, and they are a world leader in the corn flour industry. They have been for the past 30 years. They have over 100 plants worldwide and produce over 50 different types of corn flour. Their main products, which some of you may know, are flour, tortilla chips, flatbreads, and other corn-based products. All right. Azteca Milling has one location in Evansville. It was built in 1995. It has doubled production by 1996 to meet the regional demands. So they're ever expanding. At the moment, they have gone through two expansions and are looking into their third expansion. That's where we come in. At the moment, they have 3 product sizes. They are the 2-pound bag, which is for commercial sales, like Walmart and other, like other stores. Then they have the 50-pound bag, which is sold to like food-based or people in the food industry, so like restaurants and other food industry people. And then we have the 2,000-pound bag, which goes to manufacturers of corn-based products. So, for example, Mission is they're a company that makes tortillas, and that's one of the places to which they sell their product.
So shown here is the Azteca Milling facility in Evansville. As you can see, it's located at the corner of Baseline Road and Highway 41 North. What happens is the semis come in right here, where they drive around and they unload their raw corn into these silos to be stored. Once stored, or after they're stored for a few days, they move on to the processing center to be turned from corn into corn flour. After processing, they move on to another set of silos to be stored again, and then onto the packaging and warehouse area, and that is where our project is taking place. So some project requirements for the firewall. First off, the firewall will be moving 20 feet north of its current location, and when that happens, it'll be cutting off a fork truck path, and it will be hindering their access to a flow rack storage equipment. And so the first deliverable is we have to make the firewall comply with OSHA regulations. Secondly, the firewall must allow safe access to the rack storage equipment. So as I mentioned, when we move forward, it'll make it difficult for them to reach their storage equipment. We have to find a countermeasure for that. 2 constraints. First, the total storage capacity of the rack equipment cannot be changed. It can be altered, however, we cannot lower the amount of storage capacity. Secondly, the pickup points from packaging have to be relocated. Currently, the fork trucks pick it up right from the packaging station and take it on to the warehousing operations. When we get rid of that fork truck path, we have to create alternate pickup points. So shown here are 2 main sections: warehousing over here, packaging over here. Circled in red is the firewall that we're talking about, and we will be moving it north 20 feet. So when that happens, it will get in the way of the flow rack equipment, and it'll also cut off this fork truck path. The project requirements for the fork truck traffic reduction. There are 3 main deliverables. First, the traffic has to be reduced through the packaging doorway. Currently, there is a high volume of fork truck traffic through a small doorway. and we need to eliminate that traffic or reduce it. Second, the rail cars have to be accessible by fork truck. Azteca relies heavily on transportation of their goods, especially by rail car. So we have to make sure they can continue their daily operations by sending their product out through the rail cars. And then lastly, two-way traffic is desired for the fork trucks. Like I mentioned, right now they're doing one-way traffic through a very small doorway, and it hurts their efficiency in the warehouse. So we look to expand on that with two-way traffic. Some constraints, first and most importantly, is safety. So our design will be very safe, make sure that all their employees get home safely at the end of each day. Second, the current doorway cannot be altered. We talked to the owners and they assured us that right now it's going to stay the same width that it is, so we can't change the width of the doorway. And then lastly, there is small ventilation equipment just on the outside, on the south side of the warehouse. So if we were to do any type of addition to the back side, we would have to relocate or move that ventilation equipment. Shown here is the area in question. Again, over at the west side is the warehousing, right here the packaging building, and then the loading dock area right here. And as you can see, the fork truck traffic currently moves from the warehousing through the small doorway located or circled in red, past the ventilation equipment, and then onto the loading docks. There are 2-pound, 50-pound, and 2,000-pound bag stations. And currently, they are using the 2-pound bags. They are transporting their products both through this doorway, that's also being used to go to the loading docks, and up through this doorway.
There are three phases to the firewall relocation. Firstly is adjusting the rack equipment. Second phase is moving the firewall. And the third phase is introducing pickup points. Circle in the red is the firewall in question, and right above it is the floor rack. So moving the firewall would constrict space between the floor rack and the new firewall location. So as you can see, once the firewall is moved up north 20 feet, there will be some space problems between the floor rack and the firewall. Not only that, but the passageway for the fork trucks, which are currently going through in front of the firewall, will be eliminated. Shown here is a gravity-fed rack equipment. It's similar to Azteca's, and just like Azteca's, it can be disassembled and reassembled into different formations. For example, you can take the whole back row, disassemble it, then reassemble it off to the left or to the right, and therefore creating a different pattern. So as mentioned earlier, there's three phases. The first phase involves unloading the entire back row of storage equipment and moving all that product to temporary storage set aside by Azteca. Later, we'll transpose the back row of the equipment and move it to the western side, which we will show later. Then the second phase involves moving the firewall north of packaging 20 feet, and then we will replenish the rack equipment with the previously stored product. Phase 3 involves introducing pickup points, which will replace and substitute for the passageway, which was eliminated earlier by moving the firewall. Shown here currently, the 50-pound bag and the 50-pound bag packaging equipment and the 2,000-pound packaging equipment are using that small passageway, circled in red, to move all their product to the warehouse and to the floor equipment. So what we would be proposing is moving the firewall, of course, and then adding pickup points. For the 50-pound bag, there would be a new pickup point down there, which would go from the packaging building to the warehouse and to move all the stuff to the prospective storage places. The second pickup point involves putting a conveyor and also moving it up there. And then, as you can see, circled in yellow is the transport section of the floor rack equipment, which will give us more space between the new firewall location and the floor rack system.
So in regard to the fork truck traffic reduction, there are really three main issues. First are safety hazards caused by a lack of vision. As I mentioned, the doorway is very small, and there's a lot of people working in that area. Also, it's at a 90-degree angle, so safety hazards are a huge issue. Anybody that's not paying attention could get struck by a fork truck, essentially. Second, the width of the doorway limits the traffic. As I mentioned, their warehousing operations are very large, they're constantly moving, and they're constantly looking to increase efficiency and size. So if we were to find an alternate route, it could really help out their warehousing efficiency. And then lastly, the doorway in question could be better utilized. The doorway is currently located, as you saw, between three main sections: warehousing, packaging, and the rail car loading station. So if we were to eliminate just one of those pathways, it would be freed up for packaging, essentially, to help them out with their daily operations. Just like I showed you earlier, the fork truck traffic comes through the warehousing, past a small doorway, and then to the loading docks. Also, we have fork truck traffic coming from packaging from the 2-pound station, going through here as well. So if we freed up that space, packaging can make better use of it. So our proposed design is an above-ground tunnel addition. It goes from the warehouse directly to the loading docks, bypassing that small packaging doorway. It's designed to be 23 feet wide by 70 feet long, so wide enough for 2 fork trucks to travel through it at one time. Also, it will be covered to protect any of the finished products from weather conditions such as rain, snow, etc. And then most importantly, it will have safety precautions added. So we will have hemispherical mirrors so that anyone walking through the area can see any of the fork trucks going through. Warning signs letting people know that it is a high fork truck traffic area and that only fork trucks are allowed through the tunnel. And lights that are motion censored lights, so when a fork truck is traveling through, they'll go off so anyone in the area will know to be on their guard and look out. Here's a picture of our proposed tunnel design. It's simply an addition to the backside of the warehouse. So now traffic can go from the warehouse through our tunnel onto the loading docks, bypassing the small doorway, and bring that up for packaging to use. As I mentioned earlier, the ventilation equipment, circled here in red, it did have to be relocated roughly 50 feet west of its old location to make way for our tunnel. Also shown up here is the pickup points that Pedro was talking about for the 50-pound, 2,000, and the 2-pound bags. The pickup point for the 2-pound bag will be located right here. So the economic cost analysis for this project is divided into 2 main sections. First, an implementation cost, and then the design costs, which in this case were hypothetical. The implementation costs were $80 per cubic yard for the concrete, $7 per square foot for the cost of the structure, $10 per square foot for the labor, and then the conveyor costs were about $6,500 per 20-feet section of conveyors. Design costs, we had 2 students at roughly $15 per hour apiece, the advisor at $100 per hour for a consulting fee, and then 2 Azteca employees each at about $45 per hour. And so for the implementation costs, we have about $50,000 invested into the tunnel design, or the tunnel, implementing it, and then about $33,000 in the conveyor system to create the pickup points, for a total of $83,500. For the design costs, we have about $2,000 for the advisor, who spent roughly 20 hours working on this design. The students at $1,350, who each spent about 40 hours apiece on the design. And then 2 Azteca managers who helped us out with the, basically gave us a tour of their facility and laid out the project requirements. So a grand total of $87,068.85. So in conclusion, all of the project deliverables were met. First off, the firewall must comply with OSHA. We met that by relocating the firewall 20 feet north of its current location. Second, the safe access to storage racks must remain. We met this by rearranging the rack equipment and adding pickup points. Third, in regard to the fork truck traffic reduction, the traffic must be reduced through the packaging doorway. We met this by diverting the traffic onto an alternate route. The rail cars have to be accessible by the fork truck traffic as the 4th deliverable. And we met that by designing a tunnel to be added to the warehouse exterior. And then lastly, 2-way traffic is needed for travel to and from the loading docks. And we met that by designing the tunnel wide enough for 2 lanes of traffic. foremost like to thank our friends and family for helping us throughout the last few years of college. Dr. Marco Largracia for being a great advisor and mentor throughout all of our years. Dr. McDonald for helping us out with this project. Donna Moore for keeping everybody in check and up to date on everything. And the engineering faculty in general. You guys are all great. You always have time for us, and that means a lot. It's helped us a lot throughout the years. So thank you. Are there any questions?
Questions?
So you've done your economic analysis on how much it's going to cost to implement. Have you done any analysis of what it would save in terms of through flow?
In order to get that information, we would need information mainly from Azteca. We requested that, but we weren't able to get it.
Good job, guys. A question about the tunnel. Does that have human access? And if it does, how do you address the safety issue?
Oh, that's the thing. The tunnel will only be used for fork trucks. So now they can use the packaging doorway, travel as they need.
I like your PowerPoints to show how the phasing. Did you draw on any other CAD software to lay it out?
Yeah, it was all AutoCAD drawings.
You used AutoCAD? Okay.
Other questions?
Maybe you can comment on this. I find it a little interesting that maybe the overall design of the factory might be in question, that they have to haul all their finished product on fork trucks as opposed to having a different design where their packaging kind of feeds right into the loading dock via a conveyor system or something like that. You have a comment on that?
Yes, so as we mentioned, they've expanded a few times and they're looking to expand again. So we don't know if they've had that in mind when they first built the facility, having that high of demand for their products. So that's why they're probably resorting to fork trucks. But I will say we looked into it for the tunnel, for implementing conveyor systems and just lead right to it. However, the expense is too high, I think.
Thank you.
All right. Any other questions? Well, let's give them a hand.